Hi Science 10, welcome to the chapter 11-12 video lesson on the climate and biomes. It will be one video lesson to wrap up these two related topics. And we'll start off with a definition between climate and weather. Daily, you may talk about the weather, so that is immediately what the temperature and precipitation and humidity is at some place in time, whereas climate is a trend. It's a long-term, over many period of years, what that average temperature, humidity, and pressure would be. Climate is very important in establishing the biomes of the earth, and then therefore the organisms that can exist there. Temperature is of course seasonal, and because of moving energy and air currents and water currents, temperature changes over around the year. Altitude makes a difference as well, as warm air rises and cools as it goes up, and the water vapor or humidity in the air, the percentage is obviously going to be how much water that air can hold, and then the warmer areas can hold more water and evaporate more water. And dew point is when that water condenses and precipitates down. So greenhouse gases, I just drew on this slide that just to start off with, realizing that where we are on Earth, there is a greenhouse gas layer, and that will have, surprisingly, some people don't realize water is part of that, but water is a greenhouse gas, carbon dioxide is a greenhouse gas, methane, nitrous oxide, and several others are causing the sunshine to get sun energy to get trapped in that greenhouse gas layer and bounce back, and warms the earth, keeps that solar radiation in. And if we didn't have that greenhouse gas layer, it would be much, much colder on Earth. And the average temperature is 14, and it would be minus 19, so 35 degrees less on Earth if we didn't have the greenhouse gas layer. So we do need this greenhouse gas layer. However, if it gets thicker over time, we could be warming the Earth too much and causing things like melting of polar ice caps and all the loss of habitat for organisms that comes with that. What we have further out is the ozone layer, in case you just want to see relatively where that is. Ozone layer is protecting us. The ozone is protecting us from harmful UV radiation from the sun. And so that's why we're concerned about holes in the ozone that could be caused by burning plastics and aerosol gases that could destroy the ozone layer. So just telling you where those two layers are relative to each other. So greenhouse gases, some little picture here just showing you how they bounce, and just like I demonstrated already, bounce back. Those rays bounce back from that greenhouse gas layer and warm the earth. And we have other planets that don't have those gases, and they feel like that contributes to their very either cold temperatures or very hot temperatures, because they don't have that protective layer of gases like we do here. Venus does have a layer that you can see here that is fairly thick, that has 96% carbon dioxide, whereas we have very little carbon dioxide. And so a very thick layer here is helping with this high temperature that Venus has. Okay, so if we look at The seasons next. Seasons are caused by the fact that Earth is tilted, sitting on a tilt on its axis, and so it rotates on a tilt. So sometimes we are tilted towards the sun, and that will be when we're in our northern hemisphere will be in our summer, and the southern hemisphere, Australia, like that would be in their winter. And then in the winter time for us, we are tilted away from the sun. Here's our sun. And so we experience the colder temperatures of winter, and the southern hemisphere is getting their summer. So it's because of the way we are tilted as we make our 365 day rotation around the sun. Sometimes we're tilted towards it in the north, and sometimes we're tilted away from it. So next topic is properties of water. And water has this very high heat capacity, which we've heard of before, 4.19 joule per gram degree Celsius. So a lot of energy is needed before we can make the temperature of water go up 1 degree. We need 4.19 joules of energy for every gram of water. And so that means that oceans, large bodies of water, will need a lot of heat before it'll absorb a lot of heat before it ever changes any degrees, and water of the oceans doesn't change very much at all. And so it does a lot of absorbing in the hot hours of the day, and then it releases that stored energy in the cooler hours of the day. And same goes with absorbing a lot in the summer and releasing a lot in the winter. So those large bodies of water help to moderate temperatures for all cities that live near or are situated near oceans or large bodies of water like Great Lakes. The temperatures in those places will be more moderate because of the big absorbing and releasing ability of the water. So the heat capacity is because of the hydrogen bonds that the water molecules have between each other. And so it takes a lot of energy to break those bonds. And because of that, this high heat capacity, as I mentioned, has a moderating effect on the temperatures around large bodies of water. Here we have hydrogen bonding demonstrated that it is the bond between, because we have a polar molecule where the hydrogens tend to stick on one side and the oxygens on the other. This oxygen will be bonded strongly to the hydrogen of the next water molecule. So that bond is what gives water its characteristic high heat capacity, as well as high adhesion, sticking together. Sticking together, cohesion, and high adhesion, sticking to other surfaces. Ocean currents that are continually moving will move polar warm water. You know that the bulge of the earth means that this is more directly hit by the sun. So the hot water here is going to be moved from the equator to the poles, and that will help circulate that warmer water with the global water. And the Gulf Stream, 100-kilometer wide stream of water, flows from the Caribbean up the eastern coastline of U.S. and Canada. And so that is a way that again, there's that mixing of the ocean, or the ocean water of the world, and we have the cool water then coming down to replace it. El Nino is when these currents in the air and the water get disrupted somewhere between 3 and 7 years, giving rise to very heavy rains, particularly South America, Southeast Asia, and Northern Australia. And so that will give this humongous precipitation effect. And so we have the change in the way that the wind moves, and so those winds are moving this way, and we've got the warm water going this way, we've got that clash, and the rains will be as a result of that. On the other hand, La Nina is something that's causing colder conditions, also heavy rains, but cooler. And so you guys can watch the El Nino, La Nina video here to see the differences. But basically, El Nino, heavy rains, La Nina, cold and heavy rains. Wind currents for us are often westerlies coming from the west. And what happens is air, as convection currents work, air goes from the equator, rises up to the poles, and sinks again back down. So it is a continual circuit of moving air, and that will give us the winds coming from a westerly direction. That's why it's called a westerly. And we have a review here of La Nina, the cool area, colder years of precipitation, and El Nino, the just very heavy precipitation. Coriolis effect is how the Earth is rotating, and the atmosphere, air is rotating with it, but it tends to veer off when the Earth is turning. And jet streams, this is referring to the flowing air, is affected by the Coriolis effect, and we usually have the strongest air currents in the winter. The convection currents, as the air is hotter at the equator, tends to rise up from the equator towards the poles, as you see in this picture. Okay, rain shadow is when air is moving up over the Rockies, and as it does so, it will condense and precipitate on that side of the mountain range. And so the precipitation tends to happen here on the side that's closest to the oceans. And what happens is dry air is all that there is that's moving on to the other side. And so this is giving us Chinooks, or dry warm winds, for example, that hit Calgary, because the precipitation has happened on the other side of the mountain range. Okay, albedo is how much reflectivity happens on that surface. So a high albedo would be like shiny ice, for example, or snow covered areas, and low albedo or low reflecting would be like dark earth or forested area, because they would actually absorb the sun's rays. Climatographs are important. You should know that I'll just make it red here, the rainfall of the area in the graph is shown on the bar graph part of it, and the temperature is what the line graph portion is. So what we see here is we can quickly compare climatographs of areas that have higher precipitation, areas that have lower precipitation. Generally, the higher precipitation will be areas that are near the oceans, and lower precipitation area would be inland or like prairies. And we'll also see, as we compare climatograms, even in places like Vancouver, Victoria versus Saskatchewan, Manitoba, that large bodies of water will have this moderating effect on temperatures. So the temperatures are much less changing over the course of the year on the coast of Vancouver, Victoria, that they may have like a range of -5 to +25 maybe around the year, whereas we may go from +40 to -40 degrees and have an 80 degree range here in the prairies. So it's that high heat capacity of the ocean that takes up the extra heat and releases the heat, that's giving that moderating effect on the temperature and therefore climate. And of course, here at the bottom, these are the months, January, February, March. And so you can just take a look at some climatograms that are in your notes. Habitat, where something lives, ecosystem, the living and non-living interactions in that community, so all the organisms that live there and all their abiotic surroundings. Biomes are areas with similar climates, and usually that climate is a major effect on the climate is the temperature and precipitation of that area. So as you can see, precipitation and temperature are the two major things in this graph that's comparing the rainforest that has high precipitation and high temperatures versus tundra that has low precipitation, low temperature. So you can find all of our biomes on this graph. So I think there's 8 of them. Okay, the Gaia hypothesis is by Dr. Lovelock from NASA. His hypothesis says that our biosphere is a complex series of systems that maintains the environment for biodiversity, and so the Earth can be looked at as a living organism that adapts to changes. So 6 biomes that we're going to study, 6 major categories of biomes: tundra, taiga, desert, grassland, deciduous, and tropical. Most of you have probably heard of many of these before, but the tundra is extremely cold with very little rain, therefore very little diversity, because not too much can live there. There's generally a permafrost there, and the ground never thaws, and short seasons where organisms can't even reproduce, and so there's mostly a lot of insects. The taiga is rainy, humid in the summer, cold in the winter, summer precipitation, lots of evergreens. In desert, very little precipitation, very little plant life, and heavy precipitation. Animals have to handle the dry climate. And there are different deserts, by the way. Grasslands, a bit more precipitation here, and soil is rich, and animals are adapted to the fairly dry landscape. Deciduous forests, more precipitation, shrubs and bushes, trees, and heavier rains, lots of nutrients. And then the tropical rainforest is an area that has the very high precipitation, and the many plants and animals, very high diversity there as well. Okay, the organisms, plants and animals are all adapted to their specific biomes that they live in. A physiological adaptation would be their internal body functioning. Structural adaptations would be their physical features that help them survive in their environment, like webbed feet or feathers. And behavioral adaptations are behaviors like mating, migrating, hibernating, patterns that help them survive. So biomes change over time, as the fossil record shows, and studying that would be paleoclimatology. And so we can look at things like ice core samples, pollen samples, sediments, tree rings to see the changes that the biomes have had over time. A little video here if you're interested to watch on that. Okay, natural climate changes are due to the tilt of the Earth's axes. And of course, we mentioned that earlier, more sun getting to the part of the Earth that's tilted towards the sunshine at that time. The orbit, as we go around our 365 days to get around the Earth, says that sometimes over time they feel like our orbit has been more circular and other times more oval. So there's that possibility that could change climates over years. Continental drift over time has, the theory says that the Earth has these plates that are moving together in some places, moving further apart in some places, so that could affect climate as those move. Weathering uses up, involves physical and chemical processes as the Earth's surface is getting broken down. And if there's decomposing happening, that bacteria can use up some oxygen, release carbon dioxide, and some carbon products that break up actually the weathering can actually use up CO2 from the earth, from the atmosphere. Catastrophes, asteroids, meteoroids, volcanoes, especially volcanic dust, can cover areas of the Earth and change climate. And feedback, there's a positive feedback where something happens and it perpetuates more of the same to happen. Or so like if there was a heavy rain causing heavier rains, that would be considered a positive feedback. Whereas negative feedback would be where something happens in one direction and it causes the opposite to happen. So negative feedback is how many systems in your body work. If you're too warm, the body will do something like perspire to help you cool off. So that would be a negative feedback example. Mass extinction often coincides with big climate changes. So they believe possibly big climate change caused the dinosaur extinction. And of course, humans may have many impacts on our ecosystem, like the release of pollution and gases that can affect our climate. Check out Bill Nye, interesting videos there. Global warming, evidence is showing that the temperature has gone up in the last 100 years because of increased greenhouse gases. And so there is a concern that too much global warming will cause a lot of conditions of that are harmful to the environment, like changing climates for organisms, like melting polar ice caps, that is causing flooding on coastal areas. And also the global warming is related to or believed to cause some of the severe weather systems. And so all the parts of greenhouse gases you can see here that are being monitored because they contribute to global warming. So deforestation, another thing that can affect our climate is, so when we deforest and don't replant, that's a loss of a lot of homes for organisms and can cause drying out of the land, as it shows it in this area. Cities and forests with concrete and sidewalk blocks and buildings, they can also absorb a lot of heat, and even though forests do that, they also have that transpiration happening, whereas cities just absorb it and reflect it back, radiate it back, really with a higher temperature resulting compared to the forests. Okay, climate change, little cartoons you can check out, little videos you can check out, and thanks for